Welcome to the deep dive. Today we're going to be taking a deep dive into AI.
Artificial intelligence.
Yeah, exactly. Trying to make it, understandable for everyone.
Absolutely. And the cool thing is you don't need uh, a fancy computer science degree or anything to follow along.
Right. So we've got a ton of research, articles, all that good stuff.
Yeah, we're starting from scratch, assuming, maybe you're new to AI.
Okay, cool.
Hmm.
So when we talk about AI,
Yeah.
what are we really trying to do here? Like, what's the big goal?
The big goal, I mean, it's kind of mind blowing when you think about it, right?
Yeah.
We're basically trying to replicate this amazing learning machine we all have, the human brain.
Oh, okay. I see where you're going with this.
It's incredible, right? I mean, think about it.
Yeah.
Your brain can learn languages, recognize faces, it can even compose music.
All while using how much energy?
Less than a light bulb.
Yeah.
Seriously.
That's insane.
Yeah, it's mind-bogglingly efficient.
It really is. So the question is,
Yeah.
can we capture even like a tiny fraction of that?
Yeah,
Put it into a machine.
that's the dream,
Yeah.
right? Like,
Yeah.
what if we could? The possibilities.
Limitless innovation.
Exactly. Problem solving on a whole new level.
Okay, but
Yeah.
why would we even want to do that? Like, I get it. Brains are cool,
Yeah,
but computers, I mean, they're already good at stuff.
right, right. So why bother with the brain?
Yeah, exactly.
Well, humans have always been fascinated by this idea of thinking machines, right? Like, even philosophers going way back.
Great.
Oh, yeah. They'd ponder, could machines ever reason? Could they learn and adapt like we do?
Interesting.
And then you had inventors like Charles Babbage
Oh, yeah, I've heard of them.
tried to create mechanical brains, but they just couldn't quite do it,
They couldn't learn.
Exactly. And that's the key difference, right? That adaptability.
So the brain's advantage is that it learns from examples.
Yes. Not just following some pre-programmed rules.
So we could, like, theoretically let a computer learn from experience.
That's the idea. It's the foundation of what we call machine learning today.
Okay, that makes sense.
Yeah.
So how do we actually, like, get there? How do we start mimicking the brain?
We have to zoom in, way in, to the brain's building block.
Neurons.
You got it. Those tiny messengers in our heads.
I remember learning about those in school,
Oh, yeah.
but it was a while ago.
Totally. So picture this. 86 billion
Wow.
tiny processors, each connected to thousands of others, forming this massive network.
And our brain.
That's your brain. And it's not just about the individual neurons, it's about the connections between them.
So like a giant web of connections.
Exactly. And those connections, that's what makes intelligence possible.
And early AI folks, they figured this out.
Yeah, like back in the 1940s, you had guys like McCulloch and Pitts,
Okay.
and they created the first mathematical model of a neuron.
They did.
Yeah. They showed that we could represent brain activity using math.
So someone tried to build a machine based on this.
They did. Frank Rosenblatt, 1958, created the perceptron,
The perceptron.
the first artificial neural network capable of learning. It was simple, but it proved machines could learn from data.
So it worked like our brains do.
Kind of, but it had its limits. It could
Kind.
only solve very simple problems, things that were linearly separable.
Linearly.
Like imagine you can categorize things just by drawing a straight line between them. That's linearly separable.
Ah, okay. So not the messy, complex stuff we see in the real world.
Not quite. This and the fact that computers weren't that powerful back then led to what we call the AI winter.
The AI winter.
Yeah, like a period of disillusionment, funding for AI research dried up.
So what brought neural networks back? Why keep looking at the brain?
Well, because despite those early setbacks, researchers knew the brain held secrets to powerful, efficient learning.
Okay, yeah.
It's adaptable, it learns from examples, not just rigid rules.
Right.
And it's efficient. It does amazing things with these relatively slow components, neurons.
Ah, interesting.
Plus, it's a master of parallel processing, handling tons of information all at once.
Those are all things we want in AI.
Absolutely. We're still trying to capture the essence of what makes the brain such a powerful learning machine.
So how do we go from neurons and connections
Yeah.
to a computer that can actually learn?
Well, that's where it gets really interesting. And that's where we'll pick up next time, diving into how artificial neural networks actually learn through their weighted connections and algorithms like backpropagation.
Welcome back to the deep dive. Last time we were talking about the brain as inspiration for AI
Right, the biological blueprint.
and how these artificial neural networks, learn. So we've got the neurons, the connections.
Yeah.
But how do they actually become intelligent? It can't be random, right?
You're right, it's definitely not random.
Okay, good.
One of the biggest breakthroughs was this algorithm called backpropagation.
Backpropagation.
Yeah, it's like the engine that makes these networks learn.
Okay, backpropagation. Can you unpack that a bit?
Sure. Think of it like teaching a kid to ride a bike. They wobble, they fall, but each time you give them some feedback, right?
Right.
Like pedal faster or keep your eyes straight ahead. They adjust based on that feedback.
And they get better with practice.
Exactly. So that's what backpropagation is doing for neural networks. It's giving them that feedback.
So they can learn from their mistakes.
Exactly. Let's say our network is trying to, I don't know, identify a cat in a picture.
Okay.
It takes in the image data, processes it through all those layers of neurons, and spits out a prediction. Right. Or maybe dog.
And if it gets it wrong,
Yeah,
that's where backpropagation kicks in.
precisely. It figures out how much each connection in the network contributed to that wrong answer,
Oh, wow.
like tracing the error back through each step.
Finding the source of the problem.
Right. And figuring out which connections were maybe too strong or too weak.
So it's like detective work for the network.
Yeah, I like that. And this process just repeats over and over for tons of images.
Thousands, millions.
Millions. And with each round, the network refines its connections, getting more and more accurate.
It's like practicing a skill.
Exactly. The more it practices with that feedback, the better it gets at recognizing those patterns.
Okay, but I'm curious.
Yeah.
Why so much data? Why does it need to see millions of images to learn effectively?
That's a great question.
Like, why not just a few hundred?
Well, because at their core, these networks are pattern recognition machines.
Okay.
The more data they see, the better they become at picking up those subtle patterns.
Does that separate one thing from another?
Precisely. It's like learning a new language.
Yeah.
You need to hear a ton of words and phrases in different contexts.
To actually understand, yeah.
Right. A few examples might teach the network something very specific.
But it wouldn't be able to handle all the variations?
Exactly. It wouldn't be able to generalize. A few cat pictures won't teach it about all cats.
So it's not just about quantity, it's about diversity.
Absolutely. The more varied the data, the better the network can learn the true underlying patterns.
The essence of cat or dog.
Right. Regardless of breed, color, or even, weird camera angles.
That's where big data comes in, right?
Exactly. The internet, with all its data, has been huge for AI's progress.
It's like a giant library for the AI,
I like that.
but all this data crunching with millions of connections,
Yeah,
that must take a ton of computing power.
it does. And that's where GPUs come in.
GPUs, those are those things for video games, right?
Yeah, they're great for games, but crucial for AI, too.
Really?
They're amazing at parallel processing, the kind that neural networks need.
Oh, okay.
They can handle trillions of calculations per second.
Trillions.
It's insane. They've sped up training dramatically.
So before GPUs, training a big network could take weeks or months.
Easy.
And now we're talking days or hours.
Sometimes even less. It's
Yep.
been a total game changer.
So we've got the data, the learning algorithm, and the
Yeah.
power. What's next? What are some of these advanced networks you were talking about? Welcome back to the deep dive. We've been exploring how these neural networks learn. Now I'm ready for the fun part. Like, what can they actually do?
Right. We've just scratched the surface.
Okay, good.
There are so many specialized types of networks,
Yeah.
each designed for different tasks.
Oh, cool.
Like, let's start with convolutional neural networks, CNNs.
CNNs.
Yeah, they're the masters of image recognition.
Image recognition. So, like, how my phone knows who's in my photos.
Exactly. Think about how you recognize a cat in a picture, right?
Okay, yeah.
You don't analyze every single pixel.
No.
You look for key features.
The ears, the tail,
Great. Your brain breaks the image down
into parts.
and combines them to understand the whole thing.
So it's about the relationships between those pixels.
Yes, not just the pixels themselves.
To see a shape and object.
That's exactly what CNNs do.
They do.
They have these layers, convolutional layers, that act like filter. Yeah. They scan the image for specific features like edges, corners, textures.
Okay.
As information flows through the network, those basic features get combined into more complex shapes.
Individually.
The network can recognize the whole object, like a cat, a car, even a face.
So it's like a hierarchy.
Yes. From simple shapes to complex objects.
So CNNs are behind a lot of the image stuff we see today.
Absolutely. Self-driving cars, medical imaging, facial recognition.
Wow.
They've changed how computers see.
That's incredible. Okay, so CNNs are the visual experts.
Mm-hmm.
But what about other data?
Mm.
Like language, music, it's all sequential.
Right, the order matters.
Yeah, like a sentence only makes sense in the right order.
Exactly. For that, you need recurrent neural networks, RNNs.
RNNs, okay.
They handle data where the sequence is crucial.
So understanding a sentence
Yeah. You need to process the words in order.
to get the meaning.
And RNNs, they have this unique ability
Yeah,
to remember previous inputs.
like a memory.
Kind of. And they use that to process the current input.
Okay, I see.
It's like reading a story.
Yeah,
Each word builds on the ones before it.
creating context.
Exactly. RNNs are perfect for things like language translation,
Oh, cool.
speech recognition, even predicting stock prices
Really? They can do that.
based on historical trends. Yeah.
Wow, that's amazing.
But RNNs, they do have their limits,
Oh, what kind of limits?
especially with very long sequences.
Okay,
They can struggle to remember information from the very beginning.
like if a sentence is really long,
Or a piece of music is super complex.
it might lose track.
Yeah, the early parts can get lost.
So what's the solution?
That's where transformers come in.
Transformers, is that what's behind ChatGPT?
You got it. ChatGPT is powered by a type of transformer called GPT.
Wow. Well,
And the key here
Yeah.
is attention.
attention.
Remember how we talked about the brain focusing on the important stuff?
Yeah, yeah,
Transformers do that.
you do.
Instead of step by step, they look at the whole sequence at once
The whole thing.
and they figure out which parts are most relevant to each other.
So it's like getting a bird's eye view.
Yeah, exactly. Like seeing the whole sentence all at once.
Not just word by word.
And that means they can handle much longer sequences than RNNs,
I see.
and they're faster because they can process it all in parallel.
So they're like super-powered RNNs.
You could say that.
They can understand the nuances of language,
Mhm.
even generate human-quality text.
They're pretty amazing.
That is incredible. So are transformers like the peak of AI?
They're definitely a huge leap forward,
Okay.
but the field is constantly evolving.
Right.
Researchers are always pushing the boundaries.
So there's more to come.
Oh, yeah, lots more. And as we learn more about the brain, it'll inspire even more innovations.
So AI is still in its early stages.
Absolutely. The quest for truly intelligent machines, it's just beginning.
This has been an amazing deep dive.
Yeah, it has.
From those tiny neurons to these mind-blowing transformers.
It's incredible how far we've come.
It makes you wonder what the future holds.
It really does. It's a fascinating field.
I'm leaving with more questions than answers.
That's a good thing. That's what keeps us exploring.
Well said. Thanks for joining us on this deep dive into AI.
It's been a pleasure.
Remember, everyone, stay curious. We'll see you next time, ready to explore something new.